Hello, welcome to Introduction to ECMAScript 6. I'm Brett Nelson, a mobile developer with Magnet 360, a Mindtree company. We have offices across the United States and in Europe. You may be wondering what ECMAScript is if you wandered in here just looking for a place to sit. ECMAScript is the standard that JavaScript is based on. It's controlled by the ECMAScript International, an organization in Europe that has technical committees that maintain certain standards. Officially, ECMAScript 6 is referred to as ECMAScript 2015. It was finalized in June of 2015. They changed the name to reflect the yearly release date as they're transitioning to yearly releases. It was the first release since 2011. There was a long delay between releases because they had decided on a larger scope for the next version of ECMAScript, and waiting until things were finalized took longer than they originally scoped for. After this release with ECMAScript 2017, they moved to the yearly release plan where they only make a release of the products that are definitions for things that are already complete. So rather than waiting for something new to be completed, they release what they have and move on to the next version. Obviously, they've already released ECMAScript 2016 in June of this year, so they're sticking to yearly release schedules going forward. Since it is JavaScript and we're talking about web browsers, you may be wondering how to use ECMAScript. Sorry, I'm going to stop calling it ECMAScript 6. ES6 for short, or ES5 for ECMAScript 5, the previous version. So you may be wondering how to use ES6 in a web browser that's older or may not have all the features that you want to use. You would use a transpiler, which is a fancy way to say you take it from one language that a programmer can program and compile it to another language that a programmer can also program, unlike a compiler that takes it from a programming language to machine-readable code. There are three main versions that are out there. Babel is a community-ran version that was started by members of the JavaScript community. Treasure was started by a member at Google. It was working with, and he was using it while playing around with the original version of Angular. And TypeScript is a superset of JavaScript that also implements types, but you don't have to use the types. You can write the ES6 syntax and have it transpiled down to ES5 syntax. So you don't necessarily need to use the TypeScript features. And we're done with slides. So the first thing we're going to look at is block scope variables. You may be wondering what that means. The scope is how long an object stays in memory. Block scope variables means the object would only stay in memory for the period of a block of brackets. With ES5, to achieve block scope variables, you would have to call a new function, since ES5 and previous versions of ECMAScript were only function scoped. So you could have a variable declared in an if statement and the body of an if statement, but it would still be accessible after the if statement was open or closed. So to create a scope in ES5, you would have to create something similar to this, iffy, an immediately invoked function expression, where we are declaring a function and immediately invoking it and passing in the variable public message that we've assigned message to. And when we run this, you'll see, okay. If we run this, we'll see that you cannot access the something I don't want to share. So it throws an error because something I don't want to share is not defined. So we comment it out, and the code will run, preventing us from accessing things that we don't want necessarily to leak out into the broader scope of things. To accomplish the same thing in ES6, we have the same public message, and we have just brackets to create a block. Now, block scope is not applicable to the var keyword. So in this example, when we run it, our secret message is available after the scope. But if we change the var keyword to the let keyword or the const keyword, which were introduced with ES6, the scope is only maintained within this block of brackets that it's in. So when we run this, we'll get the something I don't want to share is not defined error. We can also, that's the same with the const keyword, if I spelled it correctly. Good thing it's not a spelling test. Same error since const is out of scope after this bracket. If you've been looking ahead, you may be wondering what a template literal is, since it sounds pretty fancy. It's a new way to say string. So with template literals, you're able to do things like multi-line strings or variable evaluation and evaluating methods or functions within a string. So you can accomplish the same thing like multi-line strings in ES5, creating a string and then adding your special characters like the new line character. And if you wanted to make it so that you could easily look at it in the code rather than having it all on one line, using creating one string on each line and concatenating it with the plus sign. If we run this code, you'll see we get a nice little cloud. Isn't it lovely? But to accomplish the same thing with ES6, we can use the string or the template literals. It uses a backtick character rather than a single quotes or double quotes. And rather than needing to add in separate special characters for new lines or tabs, you can do the spacing however you feel is most appropriate, and it'll evaluate it so that it looks appropriate. Here, we're escaping the backslash so that it shows up. And we get our nice fancy cloud. Evaluation of variables, with ES5, you would concatenate the strings and either if it wasn't a string itself, you would use a toString to force it into a string, or you would rely on type coercion to automatically assume, since you're adding one object to a string, that it's going to be a string. So with the ES5, you have your string, and then you add it to the object, and then a new string at the end. And if we run this, we'll see that we have an error message. We're formatting an error message, so to speak, and it's, we can create dynamic content that will go in here in the dynamic content spot, so depending upon what the error message is we receive, it'll change accordingly. With ES6, if we want evaluation of a variable within a string, rather than creating multiple different string segments, we can create one string segment using the backticks and put the variable inside of the variable declaration there. It uses a $sign and open and close brackets, and it'll evaluate the values and insert it into the string. So our success message is easier to build since we're typing less and having less potential for errors. The string interpolation, or the template, the interpolation is evaluating something and returning a new value. So in this case, we want to create a sentence that takes the value of 1 and 2, performs math, adds it into this sentence. So we have multiple strings assigned or created, concatenate them, and because we don't want type coercion to force 1 and 2 to print out as 12, we have to wrap those in parens. And when we run this, we'll get our lovely string sentence. I can add 1 plus 2 and it equals 3, but it takes a lot of work. For ES6, we can do the same thing, and similar to the evaluation that we're doing right here, we just do 1 plus 2. Less work, less to fiddle with. You don't have to worry about whether or not, did I have single quotes when I started, double quotes? So. Arrow functions. is a shorthand syntax for creating a function expression. So traditionally, it would, it also binds its lexical, it binds this to the lexical surroundings. So rather than having to store the value of this, in this case, this ES5 example, we're storing this in self. So in the callback, we can reference self, increase the counter, and print it out, excuse me. So when we run this code, we'll see it count. Not too fancy, but when you do things that require callbacks, you obviously need to capture the self, or the this, so you can reuse it later. But with ES6, rather than capturing the self, since it's lexically scoped to the surrounding code, or bound to, excuse me, I'm sorry about that. Since it's bound to the scope of the object that it's called from, we don't have to capture this. We can just reference this in here, and you'll see this creates this, or returns the same results. So we're counting, if we were to log this here, so here, if you log this, you're getting an object called timeout because that's what's actually calling it. So the self, when you log self, it's not showing up because I'm running it off the screen. You see it's a simpler object with just the counter. With ES6, the same thing is accomplished or visible by just using the this. Default parameters are another feature that were added. With a default parameter, sometimes you have a method or a function that you have multiple parameters for, and you want to be able to sometimes pass in 2, sometimes pass in 3 values, but have the later ones be optional. With ES5, you would have to check the type of the passed in variables, and if they were undefined, assign the value that you wanted as the default. So on everything that you wanted to have a default parameter, you would have to do something like this. In this example, we're multiplying, and if the second value is not 1, or not defined, we pass in we use 1 instead, and then we just execute the multiplication. So we have 3 examples where we multiply 5 and 9, and in the second example, we multiply 7 and undefined. And in the third example, we multiply 3 by nothing, and I messed it up. So here we see the expected results of 5 times 9 is 45, 7 times itself is, or 7 times undefined is still 7, and 3 is so lonely by itself. But with ES6, we can define a default parameter. Rather than having to have an if statement, we just use the equals and the value that we want it to be in the parameter declaration. So much cleaner code, easy to wrap your head around. You don't have to look at it and see if there's any typos. It's pretty hard to mess up the equal sign. If we execute this code, it's going to perform the same multiplication. 5 times 9, 7 times undefined, and 3. And we get the same results, mostly. Let's close some things up. For classes, have you really used classes in ES6 if you're just doing jQuery? Or if you're using, even if you're using Angular, are you going to do prototypical inheritance? Most people aren't going to take, it's complicated. You don't necessarily take the time to figure it out. You have new people coming on the team and they're like, what is this prototype thing? You know? But here's an example anyway. We're defining a car, and you can tell it's a special class because I capitalized the C, right? So I want to use that with the new keyword. And I'm going to assign values or parameters to the prototype, not parameters, I'm sorry, method calls, so that when I get color off the car, I can return the color. And if I do this right now, you'll know that it runs. My color is white. Now I want to create another car based on that car. So I have a second one that's capital J, Jalopy, and I'm going to pass in a color and an oil level. I'll use, in the constructor, I'll use the call method so that I'm calling the constructor off of the car with a this from Jalopy so that color gets assigned appropriately. Let's pretend I'm doing something more complicated than assigning it to color, and I want to maintain the ability of whatever it's originally doing. But then we also store the oil level. Then we have to go through the process of creating the prototype off of the prototype of car, and then storing the new constructor that we defined up here in the prototype constructor of Jalopy, which seems weird because we just defined it, but whatever. We also create our new method called checkOil, and it'll do some magic and return the new oil level every time you check it. And then we'll declare it and see what happens. So if we run this, we'll see that if you look at my car color, it's white. And if you look at my Jalopy's color, it's rust. And the oil level is at 32%. I just put 100% of oil in it. What? That doesn't make sense. If I look at the ES6 car, though, I have the same car defined at the top that we started with as the base class. Rather than using the function keyword, I use a class keyword. So there's more to rely on to know that this is meant to be used with the new keyword than a capital letter at the beginning of the word. I'm still using a capital letter because it's easier to, it's a general convention, so why move away from it? But the constructor, rather than being assigned as a function of car, inside the body of the car class, we have a constructor method that's called whenever the new keyword is used. We have any initializing values that we want passed in there and do the magic that we want to happen when the object is created. We also have a method down right below the constructor that I called getColor, and it just returns the color off of this. You have to use the this so that you're referencing the instance of the car that you have. You don't need to use the function declaration since it is inside the class body. If we call this or instantiate this car, we'll get the color of white. Now we made a new car underneath that, and it extends the car class. So it uses the class keyword, and it also uses a special extends keyword. And it's all syntactical sugar. Under the hood, it's still doing the prototypical inheritance. If you look at the output of Babel or TypeScript, but aside from looking at very complicated JavaScript, it'll just be doing the same thing as the other class. It just might not be the way you would have written it. But here, we have the constructor, the same thing we had with the car class, and we're passing in a color and an oil level, like our Jalopy. And rather than calling car.call.this and passing in some JavaScript magic, we just call super and pass in the variable that you're supposed to instantiate the base class with. So since our car started with a color, we just pass the color into super. And then we store the oil level similar to what we did before. And we define any additional methods that we want. So we don't need to redefine getColor since it was on the base class, but we can define checkOil, and it'll return the oil level. And I made it too small. So you can see if you look at my car, it's white, and if you look at my sports car, it's red because all sports cars should be red. And the oil level is just fine. Another thing that was introduced with ES6 was destructuring, which is taking apart an object or an array. We'll start with arrays. So let's go over the ES5 pretty quick because it's really you just access the position on the array. So not terribly complicated, but you can access and assign to a variable. And in this case, we're just going to print out what's at position 0, 1, and 2. And since our array contains 1, 2, 3, 4, 5, and 6, you can see that the results are as expected. Obviously, you can do this with separate declarations, so if your variable existed previously and you're assigning a new one from the array, it's going to work the way that you would expect it. So if we run this, we'll get this wrong results because I highlighted something. You'll get the proper results if I don't highlight anything. So that's expected. Same with skipping values. Rather than looking at 0, 1, and 2, we're looking at 0, 1, and 3. If I'm going over this too fast, let me know. So if we run this code, it's pretty straightforward. We get 1, 2, and 4. But with ES6, we can decompose the array and declare it using the decomposition syntax where we since we're dealing with arrays, you use a similar characters that you use for the creation of the object. So we're using brackets to decompose the array, but the brackets go on the left-hand side. So I guess for you guys, that's over here. So normally previously you would not expect to see something similar to that in your JavaScript. So if we run this code, also, the ... rest is not a joke. I'm not just leaving it out there. It's going to assign everything that remains after position 2 into one variable called rest. And so when we see that, we have position 0 is 1, position 1 is 2, position 2 is 3, because someone named these super easy, and all the rest, so 4, 5, and 6. It also works with separate declarations, so we can have a position 0 that we have originally assigned 7 to, and position 1 that we assigned blue to, because that makes sense, and a false for position 2. Wait, messed that up somewhere. Anyway, if we run this, rather than declaring new variables when we decompose the array, we'll just reuse the ones we previously had, and you'll see that position 0 is 1, and 1 is 2, and 2 is 3, rather than 7, blue, and false. Skipping values, when decomposing this way, rather than having to change an index number, you just don't put anything there. So if you want to decompose this array, but you only want positions 0, 1, and 3, you just don't put anything in position 2. So if we decompose this, we'll have values 1, 2, and 4, if I don't have anything highlighted. So, what's that? Oh. And the rest of the array, since we skipped one of the indexes, is 5 and 6, because the remainder after you do the first 4 is only 2. Decomposing object, so that's decomposing arrays. The other thing you can decompose is objects. So there isn't really a thing for this for objects in ES5 either. But if you wanted to decompose, you would just access the property name. So I have a simple object up here, my object of value, seriously, true. So just access the value and the property of, or seriously, and it'll print out. So pretty straightforward. If you want to decompose, though, in ES6, you can also use the brackets on the left-hand side of the equal sign and use, this is an assignment operation. So we're creating new objects for message and success. And in this case, we're going to name those new objects message and success. And the way it knows which variable or which property to put into each one is based on the name. So success is going to go into success, and message is going to go into message. And Witty's second property is not going to go anywhere. As you see, we have the message and success. If we wanted to use different names than whatever was on the object, say for instance, you're accessing something that someone else created and you don't really like the way they name things, you can use rename things using colon and then the new name of the new object. This is, again, creating new objects at the time of decomposition. So if we run this, we'll see the new objects have the values of message and success. So new message, look on a message, success false. I think it's getting smart with me. If we want to assign or decompose an object, though, without creating a new object, because sometimes you want to assign it to something that already exists, you can do that. Here I have new message that has a value of nothing and succeeded equaling false. We'll log that to console to verify that they're there. But when we decompose the message container, we're going to have new message go to new message and success go to succeeded. You may notice that rather than having the var in front for the declaration of new variables, I've wrapped the entire line with parentheses. That's because if you were to run it with just the scope on the left-hand, just the brackets on the left-hand side of the equals operator, it's actually invalid syntax because it thinks it's a little block scope. So if we run this, we'll see new message and succeeded with the proper values at the end. So before new message is nothing, afterwards new message is, look, I'm a message. All right, and I think I've run out of folders to go through. Let's go back to the slides. All right. So looking ahead, as I mentioned, ECMAScript 2016 was already finalized in June of this year. They are obviously working on ES Next, or what will become ECMAScript 2017, which will most likely be finalized sometime around June of next year. It's easy to remember because it matches the year. They've moved to only including things in the standard that have been implemented in web browsers or methods. So if it's incorporated in the V8 engine from Chrome, or for Chrome, or the Chakra engine for Edge, or SeaMonkey? No. The JavaScript engine that they use at Mozilla. So unless it's already been implemented, it's not going to make it into the standard. More than likely, it has to be implemented in more than one platform. And they are including things like TypeScript, Babel, and Traceur as implementations because they are implemented. In conclusion, we talked about what ECMAScript is and how I like to call it ES6, transpilers, arrow functions, block scope variables, template literals, default parameters, classes, and destructuring. Does anyone have any questions?
Go back to the Visual Studio Code, the arrow functions?
Yes.
In the ES6 version, how do you access self here?
Self?
What happens if you
Okay.
console.log?
You're asking if, or how in the arrow function here, the body of the arrow function, you access the self of the new thing, my new thing? Yes?
Yeah.
Okay. So with the arrow function, since it's lexically scoped to the object that it's inside of, you don't need to store this in a self. So the this for the arrow function is the this of my new thing. So
So what, if you go to ES5 again?
yep.
Okay, gotcha. So probably, so we don't need to say anymore like this.
Correct. You don't need to store this in a self so you can use it in a callback. So when you have things where you need to reference the scope after it's moved on of execution, in this case, it stores it so that it knows that this for this, it is implied to be my new thing. So they call it lexically scoping. which is a fancy word for saying the parent. So, does that answer your question? Okay. Any other questions?
Yeah, you said that, you probably heard me anyway, but you said that the classes for ES6 gets transpiled
Yes.
into that prototype, excuse me, the prototype stuff we saw. What does that transpiling then? Is that the browser doing it?
Oh, no, the transpilers, those are the Babel or the Tracer or the TypeScript.
Okay, so
So
if we were using ES6 today and the browser didn't support it natively, it would get transpiled to
you would
ES5.
need to set it up and then run the transpiler. So you would do all the okay. It's possible to do the transpiling on the client. It increases load time, which I think is probably not the most ideal user experience. So you would do it during your build process. So JavaScript's getting more complicated, but you'd like Gulp or Webpack or even Babel and TypeScript, they have watch functions that watch as you change the code. So if you're doing local development, it'll refresh the browser, show you what happened or what's the new thing and how it's happening. But the transpiling is the step that would be required beforehand. However, with the evergreen browsers like Chrome, Firefox, and Edge, most of the features for ES6 have already been implemented in. So if you have totalitarian control over what your users are using, you can pick something for them.
Yeah, if only that were the case.
Yep.
Then my second question is, any tips on debugging when it is transpiled? That's one of the problems we have. If you do write TypeScript and then you're debugging in the browser and it ends up as that complicated prototypical JavaScript.
They generally create map files. Are you able to do local development or?
Yes and no.
Okay. The map files help a lot, but even with the map files, and you can set up the browser to look for the map files and the server to allow the people to use the map files. But even with that, I think it's a good idea to know, be able to understand it. I know it gets a little complicated, and sometimes it's difficult to wrap your head around, especially if you have a huge, complicated object that probably should be decomposed. But as far like the map files help a lot, and then sometimes, like depending upon what the error is, logging to console sometimes helps. Like if you, like in the TypeScript you mentioned, I've used console log, which it'll print something out at that point, but it'll also tell me where in the generated code it is. So it gives me a better sort of feel for the surroundings. So. Any other questions? Yeah. Yeah, the transpilers are also considered implementations because like Node uses the V8 engine, but it's not a web browser, but it's an implementation. Same with the Chakra engine because they have the Node adapter for Chakra. Some things like the Pebble smartwatch have implemented their own JavaScript engine. ES6 is pretty much, it's like in Chrome, probably close to like 98%, maybe more. The one thing that's always left off is proper tail calls. So it's the method to call. Like if you do recursion, it's the last one to call. So does that help? Yep. Anyone else?